Hello everyone. Let us solve problems on LPP to find basic solutions of given linear programming problem. Here problem is like this. Determine basic solutions of given problem. Here linear programming problem is like this. Maximize z is equal to, this is objective function, x1 minus 2x2 plus 4x3 subject to, these are constraints which are equations here, x1 plus 2x2 plus 3x3 is equal to 7, 3x1 plus 4x2 plus 6x3 is equal to 15. These are constraints and this is objective function. Okay. Now what we have to do in solution, first of all we have to find out number of variables. How many variables are there? In constraints as well as in objective function there are 3 variables, x1, x2, x3. So m is equal to 3. N is number of constraints. Only 2 constraints are there. This constraint 1 and this is second constraint. So only 2 constraints are there. So n is equal to 2. We have to find out this difference m minus n, which is equal to 3 minus 2 is equal to 1. Meaning of this 1 implies, meaning of this is what? Give 0 value to 1 variable. Means there are 3 variables x1, x2, x3. First of all give value to x1 as 0. x1 is equal to 0. Then if we substitute x1 is equal to 0 in constraints, then 2 equations you should get. That 2 equations will be 2x2 plus 3x3 is equal to 7, 4x2 plus 6x3 is equal to 15. That equations you have to solve and get the values of x2 and x3 like that. Okay. So prepare table like this. You have to prepare table like this type of table. In first column xi is equal to 0, which variables you are giving value 0. Okay. Second column equations, putting xi is equal to 0 in constraints, 2 equations will be there. That 2 equations you have to solve and get the values of variables whatever may be that. Okay. Third column, that is value of z. Put the values of x1, x2, x3 and get the value of z. Z is objective function. You have to find out value of objective function. Then third column, that is degenerate. We have to know about, is the solution degenerate or non-degenerate. Okay. When we can say degenerate, if any one variable is having value 0, excluding this one, any one variable from the solution of these 2 equations, any one variable is having value 0, then it will be degenerate. We can put here yes, it is degenerate. If suppose both the variables are having values is equal to 0 or greater than 0 or any positive number, then that solution will be known as feasible solution, otherwise not feasible. You can put here no. Okay. If any one of these 2 variables is less than 0, suppose negative, means it is not equal to 0 or greater than 0, then in that case it is not feasible. If xj is greater than or equal to 0, xj means these 2 values greater than or equal to 0, then that will be feasible. Then optimal solution is what? Optimal means solution which is feasible as well as maximum value is there, maximum value of z is there, then that solution will be optimal. Okay. Whatever may be maximum value of z, you can say yes. In that row you can say yes, otherwise remaining all value that will be no. Okay. Only one yes will be there in last column, only one yes, depending upon maximum value of z, and it must be feasible. Okay. This is just concept of this problem. Now let us solve this one. First of all, x1 is equal to 0. You have to prepare table like this. Remember, x1 is equal to 0. x1 is equal to 0 put in constraints, x1 is equal to 0, then equation becomes 2x2 plus 3x3 is equal to 7 and 4x2 plus 6x3 is equal to 15. Solve these two equations simultaneously, either mathematically or you can solve these two equations by using calci also. If we solve these two equations by using calci, you should get maths error or syntax error, maths error or syntax error. In that case, meaning of that, we will not get values of x2 and x3. You can try, you will get maths error. Okay, then in that case x2 and x3 it is not possible to get the values of x2 and x3 from these two equations, solving these two equations. Okay, then this solution is known as unbounded. So you can put here value of z, putting x1 is equal to 0, value of z here in objective function, x1 0 रहेगा तो -2x2 plus 4x3, z is equal to, but x2 and x3 which are not means if we solve these two equations, that gives maths error na, so we should not get the values of x2 and x3 here. So solution is unbounded. If solution is unbounded, then it is not required to find to know about that solution is degenerate, feasible or optimal. So you can put here dash dash only, dash dash and dash. Okay, now move towards second row. Here we are assuming x2 is equal to 0, x2 is equal to 0, second value, second variable is 0, out of x1 x2 x3 second variable x2 is equal to 0. Then if we substitute x2 is equal to 0 in constraints, then equation becomes x1 plus 3x3 is equal to 7 and 3x1 plus 6x3 is equal to 15. These two equations, x1 plus 3x3 is equal to 7 and 3x1 plus 6x3 is equal to 15. Solve these two equations simultaneously or by using calci, because using calci you can solve up to 3 equations. Okay, means equations up to 3 variables and equation having degree 3. So there are only 2 equations you can solve by using calci. After solving these two equations simultaneously, we will get the values of x1 and x3. x1 will be 1 and x3 will be 2. Okay, here x1 and x3 both are positive, both are positive. Okay, any one of the value is no one value of these two is 0. So is this degenerate hai? No, because no one value is 0. So here you can put no. This solution is non-degenerate. Okay, and if we substitute x1 is equal to 1 and x3 is equal to 2 and x2 is equal to 0 in objective function in this equation, then you will get value of z, that is equal to x1 is 1 and x3 is 2, 1 plus 4 into 2, that is 9. Okay, is this degenerate? No, because no one value is 0. Then is this solution feasible? Feasible hai? Yes, it is feasible because these values x1 and x2 both are greater than or equal to 0, both are positive. So this solution is feasible. You can write here yes, given solution is feasible. And this finally, okay, in final step, third last column. Now here substitute x3 is equal to 0 because optimal solution depends upon feasible solution as well as maximum value of z, maximum value of z. We have to find out third value. Third value means for x3 is equal to 0. So third row, x3 is equal to 0, put x3 is equal to 0 in constraints, then first constraint becomes x3 is equal to 0, then x1 plus 2x2 is equal to 7, 3x1 plus 6x3, 3x1 plus 4x2 is equal to 15. We have to solve these two equations simultaneously. x1 plus 2x2 is equal to 7 and 3x1 plus 4x2 is equal to 15. Solve these two equations simultaneously either by mathematical method or simultaneously or using calc, we will get value of x1 is 1 and x2 is 9. x1 की वैल्यू 1 and x2 की वैल्यू 9 मिलेगी. Put these two values in z considering x3 is equal to 0. z में पुट करेंगे तो आपको z की वैल्यू मिलेगी x1 minus 2 x2, 1 minus 2 times 1 minus 2 times x2. x2 is 3, 1 minus 6, that is minus 5. Now we have to know about, is this degenerate? Degenerate means what? कि ये degenerate है क्या? Because x1 is 1 and x2 is 3. No one value is 0. So this solution is non-degenerate. So we can write here no. But is this feasible solution? Yes. This is feasible solution because x1 and x2 are having positive values 1 and 3. Okay, so it is feasible. Now you can obtain optimal. Now here 9 is positive value which is greater than minus 5. Okay, this is positive value which is greater than minus 5, and this is maximum value of z. And feasible solution, yes, it is feasible also. So we can say this solution is optimal. We can put here yes, and for remaining values it is no. Okay, this is solution for this sum. We have obtained basic solutions like this. इस तरह से हमें बेसिक सॉल्यूशंस निकालना पड़ेगा. ठीक है, तो ये बेसिक सॉल्यूशंस मिले हैं. ऑप्टिमल वाला पार्ट जो है, दिस लास्ट कॉलम, हमें जब वैल्यूज ऑफ जेड पूरी मिल जाती है तभी हम ऑप्टिमल है या नहीं ये डिसाइड कर सकते हैं. वो भी फिजिबल होना चाहिए. फिजिबल यानी कि यस आना चाहिए. यस के लिए ही मैक्सिमम वैल्यू जेड की कौन सी है वो देखने का, क्योंकि प्रॉब्लम जो दिया है मैक्सिमम टाइप दिया है, मैक्सिमम. सो मैक्सिमम वैल्यू देखना है. अगर प्रॉब्लम मिनिमम टाइप होता तो मिनिमम वैल्यू देखना पड़ता. मिनिमम वैल्यू ऑफ जेड एंड इज इट फिजिबल वो देखना पड़ेगा. फिजिबल भी होना चाहिए और मिनिमम वैल्यू भी होना चाहिए अगर वो ऑब्जेक्टिव फंक्शन मिनिमम टाइप होता तो. लेट अस सॉल्व नेक्स्ट सम विच इज yes, this one. Let us solve this sum. Yes. Okay, let us solve this sum. Same type. Determine basic solutions. Here also we have to know about basic solutions. Basic solutions find out करना है. 1 minute. Okay. Determine basic solutions for given linear programming problem. Maximize z is equal to 2x1 minus 2x2 plus 4x3 minus 5x4. Subject to these constraints, there are only two constraints: x1 plus 4x2 minus 2x3 plus 8x4 less than or equal to 2, minus x1 plus 2x2 plus 3x3 plus 4x4 less than or equal to 1, and these are restrictions. All four variables are greater than or equal to 0. This is also maximization type problem. Objective function is maximized type. Four variables are there: x1, x2, x3, x4, and only two constraints are there. Four variables, two constraints. So m is equal to 4 and n is equal to 2. Difference m minus n is 4 minus 2 is equal to 2. 4 minus 2 is equal to 2. Okay. So put values of two variables 0, means give 0 value for two variables. There are four variables. How many ways will be there? you can find like this. Keeping x1 0, one more value of x must be there. X1 is 0. With this you can make a pair with x2, that is first way. X1 x3, that is second way. Okay, then x1 x4, that is third way. These three ways. Okay, then start from x2, x3, that is fourth way, x2 x4, that is fifth way, and then start from x3, x4, only one way, that is sixth way. So there exist 6 ways. Considering two variables is equal to 0, means 6 steps are required. Okay, prepare table like this, similar to previous. Here also values of two variables. Here we have to put two variables is equal to 0 in constraints and get two equations using constraints and solve that two equations. Xi is equal to 0, xj is equal to 0. Second column of equations. Third column value of z. Fourth column degenerate. It is degenerate if any one value of these variables is 0. Excluding this, don't consider these values. Okay, if xk is value of variable x is 0, then it is degenerate, otherwise non-degenerate. xk greater than 0 और इक्वल टू 0 डिजेनरेट रहेगा और बाकी सभी वैल्यूज पॉजिटिव रहेगी तो फिजिबल रहेगा. फिजिबल की कंडीशन क्या है? xk मस्ट बी ग्रेटर देन और इक्वल टू 0 एंड ऑप्टिमल इन लास्ट स्टेप. Optimal solution, is it optimal? When we can say optimal, solution must be feasible as well as having maximum value, which is known as favorable value. Okay, favorable value or maximum value, then that solution is optimal. Here total 6 ways are there. 1 2 3 4 5 6. Out of these 6 ways, any one will be yes, remaining all will be no, with no remark in last column, means in optimal solution column. Only one will be yes and remaining all will be no, with remark no. Okay, first of all let us solve. Considering first way, that is x1 x2 0, x1 and x2 are 0. Considering this, x1 is equal to 0, x2 is equal to 0, put these two values in constraints, this 0, this 0, then only these two terms remains. Minus 2x3 plus 8x4 is equal to 2, not less than or equal to. This is in problem. Okay, but at the time of solving problem you have to consider equations. So minus 2x3 plus 8x4 is equal to 2, and second equation will be 3x3 plus 4x4 is equal to 1. Put here. Use calci and find the values of x3 and x4. We will get x3 is equal to 0 and x4 is equal to 1 upon 4. Okay, same values you have to put here and get the value of z. अगर हम z is equal to find out करना चाहते हैं तो यहाँ पे put करो x3 is equal to 0 and x4 is 1 by 4. तो what will be z? z will be minus 5 by 4. z का वैल्यू मिल गया minus 5 by 4. Okay, that is minus 1 upon 2, minus 1.25, minus 5 upon 4. Now second way, or you can say second step, we are assuming x1 is equal to 0 and second way, that is x3 is equal to 0. So x1 is equal to 0 and x3 is equal to 0, we have to put in constraint. This is 0, this is 0. Remaining terms 4x2 plus 8x4 less than or equal to 2, that will be here 4x2 plus 8x4 is equal to 2, and then 2x2 plus 4x4 is equal to 1. 2x2 plus 4x4 is equal to 1. Solve these two equations by using calci. Then you will get maths error. Mathematical error means we could not get the values of x2 and x4 here. Okay, so you can write here solution is unbounded. Just put solution is unbounded in z column, or you can put here also solution is unbounded. Okay, then everywhere you can put like this, not applicable, not applicable. Means we could not find, we cannot say solution is degenerate, feasible or optimal, because this is unbounded. Means these two equations we can't solve. We will get maths error if we solve by using calci. Okay. Then third way is what? X1 and x4 0. X1 x4 0 means x2 x3 will be non-zero. So considering x2 and x3, 4x2 minus 2x3 is equal to 2 and 2x2 plus 3x3 is equal to 1. We have to solve these two equations. 4x2 minus 2x3, 2x2 plus 3x3 is equal to 1. If we solve these two equations by using calci, that gives x2 is equal to 0 and x3 is equal to half. Okay, put these two values in Z, that will be x2 is 0, x3 is half. 1 minute, minus 2x2, x2 is 0 and x3 is half. So here 4 upon 2, that will be 2 na, minus 2x2 plus 4x3. What will be this value? That will be minus 2x2 plus 4x3. x2 is 0 and x3 is half. That will be 2. Z is equal to 2. 1 minute. x2 is equal to 0 and x3 is equal to 1 by 4. Sorry, minus 2x2 we have to put here in objective function, minus 2x2 plus 4x3, minus 2x2 plus 4x3, it is 2, 4x3 it is 2, plus 2. Okay, plus 2. Yes, plus 2. And then fourth way, that is x1, starting from x1, that three ways, previous 3 ways. Now start from x2, x2 x3, x2 and x3 are 0. Now x1 and x4 will be non-zero terms, non-zero values. So x1 and x4, x1 plus 8x4 is equal to 2, x1 plus 8x4 is equal to 2, and then second equation will be minus x1 plus 4x4 is equal to 1, minus x1 plus 4x4 is equal to 1. If we solve these two equations by using calci, we will get x1 is equal to 0 and x4 is equal to 1 by 4. x1 is 0, here already x2 0, x3 0, x2 0, x3 0. So 2x1 minus 5x4. That will be minus 1.25. Value of Z minus 1.25. After solving these two equations, we will get x1 is equal to 0 and x4 is equal to 1 upon 4. This is fourth way, value of Z. Let us move towards way number 5 or fifth step. x2 x4 means x2 is 0 and x4 is 0. Non-zero terms containing x1 and x3. So x1 minus 2x3 is equal to 2 and minus x1 plus 3x3 is equal to 1. These two, x1 minus 2x3 is equal to 2, minus x1 plus 3x3 is equal to 1. Solve these two equations simultaneously or by using calci. We will get x1 is equal to 8 and x3 is equal to 3. Two values of x1 and x3, 8 and 3. Okay, Put these two values in z. Z is equal to 2x1 plus 4x3. 2 into 8 16 plus 4 into 3 12. 16 plus 12, that is equal to 28. 28 value. Okay, this is fifth way. And now last way, that is x3 x4. X3 x4. X3 is 0, x4 is 0. Only remains non-zero terms in terms of x1 and x2. So x1 plus 4x2, x1 plus 4x2 is equal to 2. This is first equation. Minus x1 plus 2x2 is equal to 1. These equations. X1 plus 4x2 is equal to 2 and minus x1 plus 2x2 is equal to 1. Solve these two equations by using calci. Then x1 is 0, x2 is equal to half. Put these values in z. Z will be 2x1 minus 2x2. That will be what? 2x1. That is 0. And x2 is half. So minus 2 divided by 2, that is minus 1. Value of z is minus 1. Okay, value of z is minus 1. Now let us know about, is the solution degenerate? Here x3 is 0, x4 is 1 by 4. x3 is 0, any one value is 0. So it is xk is equal to 0, degenerate. Yes, we can say yes, it is degenerate. Is it feasible? You can see x3 and x4 both are having 0 or greater than 0 values. Okay, means xk is greater than or equal to 0. So it is feasible also. Yes, it is feasible. We can say it is feasible. Now this is unbounded. It is not required to know about that solution is degenerate, feasible or optimal. Now then third step. Here values of x2 and x3 are, x2 is 0 and x3 is half. x2 is 0, non-negative, x3 is half, which is positive. So it is feasible. And is it degenerate? Yes, it is degenerate due to this 0. So we can say yes, and here also yes. Yes. Okay. Then fourth, x1 is equal to 0. Any one value is 0 means it is degenerate. We can say yes. And 1 upon 4 greater than 0. So we can put here yes. This solution is feasible. Yes. Okay. Now fifth step and sixth step. In fifth step, no one value is 0, means x1 is 8, x3 is 9. No one, x3 is 3. No one of these two values is 0. So this solution is non-degenerate. So you can put here remark no. Okay. And here x1 and x3 both are positive. So it is feasible. This is feasible solution. Last step, here x1 is 0, x2 is half. x1 is 0, yes, it is degenerate solution. X1 is 0, x2 is half, means both variables are having values greater than or equal to 0. So it is feasible. Okay, here in this way all solutions are feasible. No one value is yes. Now we have to know about optimal solution. When we can say optimal, largest value, maximum value of z is what? Minus 128, minus 1.25, 2, minus 5 or 4. These and these values are negative. Only this is this is positive and this is positive. In positive values, 28 is greater than positive, most positive. Okay, maximum value. So we can say only here you can say yes, it is optimal when x2 is equal to 0 and x4 is equal to 0. Solution is optimal. Okay, solution is optimal. And everywhere you can put no. okay, and here also no. In this way you can solve such type of sum for finding basic solutions. So this is regarding basic solutions of linear programming problems. Thank you all.